All right, everyone, we are going to go through our question 3 for our exam 1, excuse me. So let's go ahead and we're going to start by doing some definitions, and we'll define those in R. Let's move this over here. So let's go ahead. Let's see, material tested. So let's see, our number of 1 measurements is equal to 14. Our number of, let's see, our x of 1 is 12. Actually, let's see, x1 is 12. Our s1 goes to 0.15. Our n2 goes to 60. Our x2 goes to what? 14. And then our s2 goes to what? 2. And then our n3 goes to 23. Our x3 goes, or x3, actually x3 goes to 13, and then our s3 goes to 0.7. All right, so we've got those defined now. We have, and actually let's make sure that we've already defined these functions. Define. So let's go ahead and let's run through our analysis. So first question is asking us, does material 2 come from a population with a mean of 13? So I'm going to do this first. So our H naught is going to be mu is equal to 13. Our alternative is it's not 13. 3, our confidence interval is 99%, or our alpha is equal to 0.01. Our T experimental, we're going to calculate that right now. So we are looking at material 2, so we are going to be doing, what's our function? TXP, actually let's just do it up here. TXP, and then our X bar is going to be X2, our mu naught is going to be 13, our S2, and then our N2. So our T experimental is 3.87. And now we have to find our T. It's alpha over 2, so 0.005. And then our nu is, in this problem, material 2 is tested 60 times, so it's infinity. And this is going to be equal to, look at it up here. So 0.005 infinity, 2.576. So let's just put that in there, 2.576. So if we look at our little diagram, minus 2.576, 2.576. So we are definitely going to be in the reject regime. So our p-value is going to be less than alpha over 2. Great. Fantastic. So now that we've done it once, I'm going to kind of skip many of these steps from here on out. You should not, but this is just for you to double check your answers. So I do want to keep my little diagram here. So we need to find our T experimental. For the next problem, does material 1 come from population mean less than? So that means that we're doing with T. Alpha is going to be 0.1. Material 1 has a 13. So let's go ahead. So 0.1 and 13. 0.1, 13. That's going to give us 1.350. It's left-tailed. 350. So that means it's negative. So minus 1.350. Mean less than 11.5. And we're going to calculate that right here. So this is x1. This needs to be s1. And this needs to be n1. And then our mu naught is 11.5. Good. And we've got a T experimental value of 12. So that's going to be way over here. So that is a big old DNR, meaning our p-value is going to be greater than our alpha. Beautiful. All right. Let's keep it moving. Done. Does product 3 come from a greater than? So it's a right-tailed test. So we need our T experimental. We'll calculate that in a bit. And then our T is going to be alpha. So it's going to be alpha, and our alpha here is not told, so it's going to be 0.05. And our new product 3 is going to be 22. So let's go ahead and look that up. 0.05, 22. 0.05, 22 is going to be 1.717. 1.717. That's going to be on this side, 1.717. Our T experimental, product 3. So let's go over here. So now instead of 11.5, it's going to be 13.8. And it's going to be x2 or x3. Ooh, shoot. x3, 3, 3. T experimental is going to be minus 0.548. So it's going to be way over here, minus 5.48. Let's double check that. Yep, minus 4.58. But it's definitely a do not reject, so P is greater than alpha. Excellent. Are materials 2 and 3 different? So again, now let's look at so now what we're looking at is a comparison, but it's still a two-tailed test because we're basically asking, are they equal? So we need to calculate our T experimental. Our T is going to be, the alpha is going to be 0.1, but it's going to be 0.05 because divided by 2, and we need to find our degrees of freedom. So we're looking at materials 2 and 3. So let's do first our new comp, and then it's going to be S2, S3, N2, N3. 80, so basically infinity. So we can do, I think we just did this one, but it's a good double check. Should be 1.717, 0.05, 0.05. Oh, no, not actually. 0.05 infinity, 1.645. Good. Oops. 0.645. And T experimental. Let's go ahead. We're going to keep this new comp. And then we're going to do T test comp. And then we're just going to do our x2, x3. And there we go. Our t-test comp is 3.37. This is 1.645. So we are in the reject region, meaning that they are statistically significant and our p is less than alpha over 2. Beautiful. Done. Let's do another one. So let's see. We're looking at greater, so it's a right-tailed test now on this one. And the same thing, we need the T experimental. We know that our T, our alpha is going to just be alpha, so 0.01. And our degrees of freedom is going to be as such. So our new comp, so we're looking at material 1, material 2. So let's go ahead and do S1, S2, N1, N2. And we can copy this and just paste it here once we do x1, x2, s1, s2. Degrees of freedom, large again, infinity, minus 7 point. So this is going to be infinity. Let's look at the number, even though we know it's not going to be 01, infinity, 2.326. 2.326. And then finally, that was a negative, but negative 7.6. So we're way over here. So we are in DNR, which means our P is going to be greater than alpha. Beautiful. And finally, last one. Material 3 less than material 1. So we're doing left-tailed, so we need to make sure it's negative, whatever it is here. We have our T experimental. We have our T. Our alpha is going to be 0.05. And then we have to figure out our nu. So let's go ahead. So material 3, material 1. So I'm going to say S3, S1, N3, N1. We need to keep that consistent. Copy in here, paste it in here. And then X3, X1. Order matters, make sure. 25 this time, and 6.6. 25, so that's going to be equal to 025 or 05, 05, 25, minus 1.708, minus 1.708. Over here, that's our T experimental, so we are in a do not reject, and P is greater than alpha. There we go. That's it. That is number 3. We will see you next time. Thanks. Bye.